A very good morning to all of you, and I warmly welcome each and every one of you for the second day of the Research Week of University of Moratuwa for the year 2025. We have gotten an interesting session today, and I'm sure it's going to be just as inspiring and thought-provoking as yesterday. In academic domain, research plays a major role. Research looks at how data can be used to understand problems more clearly and make better decisions. Data visualization plays an important role in here as it turns complex information into simple and clear visuals. Charts and graphs help reveal patterns that might otherwise be missed and make the findings easier to explain to others. In short, the research and data visualization work together to make insights more accurate, accessible, and meaningful. So, ladies and gentlemen, it's high time to begin the data visualization and analytics camp centered on the theme Visualize, Analyze, and Explain with NINE. So today, we will learn how to clean, profile, and prepare research data with ease, ways to build clear and ethical visual narratives, how to generate simple predictive or segmentation models, and strategies to create reusable workflows with interactive weaves and exportable figures for papers, posters, and presentations. So to do the honors, we are fortunate to have an expert in this area, Dr. Sandhu Dasanayake from the Department of Decision Sciences, Faculty of Business of University of Moratuwa. Dr. Dasanayake's expertise in data visualization and decision sciences will help us see how storytelling through visuals can make our research truly unforgettable. So, ladies and gentlemen, without further delay, let's warmly welcome Dr. Sandhu Dasanayake to lead this inspiring session. Over to you, sir.
Good morning, and I'm sorry we took 20 minutes of your time for the preparation, and thank you very much for organizing and setting up things here. So without further ado, let me start the proceedings. So I hope my screen is visible there, and I'm a bit unsure whether the Zoom participants can hear me and see my screen. Right, cool. Now, let's start this with something interesting. Okay, so I'll share some material to start with. So you would see a link. Cool. Right. So there's a link that I want to share with you, but it's going to be a bit long link. So right. Let me share this link with you, but in a easier to find manner. So I put some. This is for the people here. I'll share the direct link with the Zoom participants. For the people in the Zoom, I'll just share the chat. So if you are joining using the Zoom, you can see the link. For the people here, I'll try to share a shorter version of the link. Right. So if you can see the link there, bit.ly 48QJJXD. Can't write it here, but I'll try to make it visible for everyone. So 48QJJXD, you should be able to visit this folder, bit.ly 48Q. So I'll check this with you, whether it's going to work or not. Right, it's working. So as you can see, there are few things that you can download at the beginning. So I appreciate if you can download the entire thing so that it will be easy. We don't need to go back and forth again and again to download. Right. So you should have this one and you can download this. So before you download it, let me share with you, it's not a spam. So you have all the materials that we'll be discussing today. There are few codes as well. So I have put the codes into text files. So it's easy. We don't need to go with the syntax errors, and also you can just copy this as well. It's a text file, but it's a Python code. So once you download it, you will see it as .text files, these four, and there would be two other materials. The first one is this one. We'll start with this. And then we have the other one, which is called credit risk analysis, which is heavily onto analytics. And the materials, the data will be here in the KNIME workshop data. So you have 4 CSV files. The first one is a very famous IRIS dataset. Then we have Titanic dataset and application record and credit record. This is for something like the credit analytics. So these are the 4 data sets, and we have 1, 2, 3, 4, 5 Python codes, and then we have the 2 materials, right? So I hope everything is clear and you have downloaded this. We'll start with the first part, which is data visualization and analytics camp. I put the name and everything so that it's more formal. So I'll start it from my computer here. Now I'm going to close this, all right? I hope you have. Okay. So I should have it somewhere here. Okay, so I have the data sets here and the material. Here, it should be here. Okay, so I'll start with this. So I need your feedback as well. It's not a passive listening sort of a thing. This is a camp. So I'll just facilitate you to go through this. So can I have a raise of hands if you have heard K9 before? Raise of hands if you have heard 9 before. Okay, so another raise of hands if you have read the data visualization banner. Okay, so it has 9, so I think you will have heard it before. Okay, so what is 9? So since you don't have much of an idea, we'll talk about what is 9. 9 is an open source analytics software, and it is actually very powerful. It is developed by Germans and Swedish researchers. So what it does is it allows you to use very powerful analytics like machine learning, data mining, data pre-processing, visualization, analytics like dashboards and everything without codes, right? So when we talk about data analytics, most of the time it gets complicated because many of us, including myself, are not really familiar with coding, right? Even though we use coding a lot in different ways, what we do is we either copy paste the code from someone else, or we try to develop it in like bits and pieces, right? You have tires from somewhere, engine from somewhere, and then the body and everything from some other. So you get at the end something like a car. It works, but when the bugs come, it's very difficult. You don't know whether it's coming from the tire or the connection between the tire and the axle because they are 2 different brands, right? So that problem is there when we are dealing with these analytics and multi type of integration. So what KNIME allows you to do is it allows you to use a standalone package. It's a Java application, and it has these nodes. So you can connect data from multiple sources, and at the same time, you can do machine learning without coding. Some coding applications are there as well, but all in all, it's very easy. So once you create the pipeline, in data science, if you have heard of it, we call this data pipelines. So there's something called ETL process, which is extraction, transform, and load. So what we do is it's like to bring everyone to the same page here today. So I'll just give you an analogy of what this entire process is. Imagine like you are using the water tap at home. So some of you might be getting water from the irrigation department directly from the water board. And some of you might have a well at home, and then you have a pump and you have the storage. So then you take it. But whatever the process or the origin of the water that you get, you should have a pipeline at home, right? So what it does is you have an inlet and then you have multiple outlets, right? So now that is pipeline. So in a pipeline, what we do is we have the inlet, we connect the large data source that is coming from the outside, and it is connected by a major line. And then depending on the need, you have outlets. So if you think about the bathroom, when you're, for bathing and all, you have a different outlet, right? The water is not as directly pressurized as you want, like it has sprinkling. But in the kitchen, you have a different way of getting the water. And when you are washing the car or with the gardening and all, you have different ways of outlets. So the data pipeline works like this. What we do is we connect the data to the large data lake, the resourceful data network, and then we take the data and we create these pipelines accordingly to our needs, right? So what NIME allows you to do is you have this entire graphical picture of that pipeline. You have the data inlet, whatever you do as blocks, you can see how it works. Now, so I'll just start with this part. What is NIME Analytics? So I gave you a broader picture of what is data ETL process and what is the need of a software like this, and some pros. There are cons as well, but I'm not going to talk about it because it's about pros today. So I'll use this and I'll explain what how to get it. So you can get it from this link. Messy, but I have put a link somewhere. You can download from NIME website. Okay, the links are disabled for this computer. So you can go to this website. You can visit this website. Zoom is getting it on the way. If it's somewhere, you can visit NIME, KNIME, and enter. This is the page, the yellow triangle kind of thing. So once you go in, it's a no-code platform. And nowadays, we usually promote no-code, low-code platforms for business applications, and it is very common for any other science and engineering applications as well. So this is the workflow that I talked about. You can create a workflow like this and work your way around. So you can download it. Go to NIME website and just download it. It's a Java application. So in Windows, you can easily run it. And if you are using a MacBook or any other, even Linux, you have the option to download the version that you want. There are always updates and also community hub as well. You can go and check whether the models that you need are already there. So the application developers, they do this. So I'll show you in a minute, not a minute, but maybe 10-15 minutes after, how we can use these community tools to use for our analytics purposes as well. All right. Now, can I have a raise of hands if you have downloaded it already, or are you in the process of downloading? So shall I give you 2-3 minutes? So it works. Okay. In the meantime, I'll go through the material. If I open it from here, it will be easy to navigate, I guess. So we are here somewhere at the starting point. So I talked about data import and integration, data manipulation, exploratory data analysis, machine learning. So here you can click it. If you have it downloaded, you can click and it will take you to the main website. Then Windows, Mac OS, and Linux, all three support it. Right. So I'll start with the application first. So you can see what I mean. So I have a fairly new version. Maybe when you download it right now, you'll get a better version than me in terms of the number, but it's the same application. So let's go to NIME. So this is how it looks. It will open. As you can see, it's a Switzerland-based company. This is how it looks. I just did what I'm going to do today, whether it's working or not. So just forget about it. Right. This is how it looks. When you open it, the application has an interface. So the handout that you see here, it is developed for somewhat an older version. Maybe in the Windows, you would see the same interface, right? Navigating the KNIME interface here. It looked like this, but I'll give you some idea of how it is working. So if you go to KNIME, if you have installed it, you'll see something like this. At the top, you have preferences. This will be useful when we are integrating different types of outside applications, like some preferences would be there. And menu will give you this thing, install extensions, which workspaces, and other options. So as I told you, this is a Java application. So once you install it, you can install other modules as well. Some extensions are there. So there's a core KNIME platform. And to that, you can include different types of other applications. You can link different types of applications to that. And that can be done from here by clicking on menu and going to install extensions. If you click on this, you would see tons of new applications developed by different communities and also different companies and based on their needs. So if you search this in Stack, I don't know whether Stack is there, but I have seen in Quora and other forums, if you search it, even Reddit, you would have a different community specifically talking about KNIME. So you'll see their own problems, right? Say someone is working in chemical and process engineering, someone is working in operations research. So they have different needs, and also some companies. So I have seen that, there was another company, like they had this IoT applications, they provide data. So they link everything, every IoT device connectors to KNIME, and then they need something else. So they request for developers to build it, or they also develop some tools and they upload it to the community. So you can vice versa work with it. The important thing is, in fact, most of the time you'll find important things if you go to the community. Okay. So this is the interface, and the welcome messages and everything are there. So what you have done previously will be here as recently used items. So to the left-hand side, you can see data applications and some news items, etc. So how to start this? First of all, there is an icon here saying create new workflow. Okay, small green, orange, like I remember it like German because it's similar. I see in German colors like this, like if you see like Deutsche Bank or something, it looks like this. So the yellow color link, click on this, create new workflow. If you click on this, it will ask you to put a name for this. So since we are just trying to get an idea about how to use it, you can go ahead with any name that you like, but something that you can remember. So I just put it RW, not obviously for initials, it's something else, like this is for research week. So I'll put 2025. And then I'll create this workflow. Now, this is the real interface, the workflow that we will be discussing. Okay. So now there are some interesting things. Now, when you remember the time that you learned Excel for the first time or Word for the first time, sometimes when you open it, it will be a bit complex or difficult to navigate, right? Because you are not exposed to it. Because now, and also now, since we are more exposed to Excel applications and Microsoft applications, we are using the terms like ribbons and the usual interface that we are familiar with. Like if you go to Excel, you see file and all these things at the top like a ribbon. So here it's the same thing, but in a different way. So the left-hand side, you would see all those icons. You have info, nodes, explorer, and now we have KNIME AI and then monitor. So as I told you, a lot of companies would like to use KNIME because it has these IoT integrations as well. So if you have a IoT sensor network, you can connect KNIME to that. Okay, so because of that, there are some monitoring and things available, but today we'll be discussing about the nodes. So to the right, if you click on the nodes, you can find thousands of nodes here. So these are those pipelines. So I started with the analogy because it's easy for us to go through that when we follow this. So these are like this pipes, connectors, all those gadgets that you want. And it's ready-made. You don't have to worry about coding them. And because of that, you can be sure of what you're analyzing. Okay. Because if you are coding and for example, if the code has errors, syntax errors, floating number issues, division by an integer, some issues. So you don't have to worry about that when you are using something like this. It's ready-made. So the nodes are already programmed for their application. So what you need to do is like point and shoot. You just put it and then use it. Okay. So let's go to our handout. The Explorer panel I explained, node repository is there, and then the workflow editor canvas. So once you create this workspace, it will be there in your machine. And whenever you refer back and forth, you can see how it works. And output panels, you can give descriptions as you like. So let's start with something. So the nodes have input ports, output ports, and configuration options. We have already created our first workflow. I didn't give a description, but you can give. Then we can start with nodes, adding nodes. We'll start with adding nodes, but there's an easy way to do it. Now, for example, if you go to your workshop folder, go to the data folder that I shared with you. Let's start with iris CSV. Go to iris.csv. Now, if you drag this to here, there's a little space there. You drag it like that, automatically the relevant node will be created. So this is a CSV reader node. Okay, like the pump. So you start with the pump. So since we have time, I'll gradually build this. So I will not go fast. Okay. So first of all, let's dive into the node. Let's go into the node and see what it is. So if you click on the node, you can see the new version has it's all easy. So you have this open dialog here. If you click on this, you can see what it can do. So you don't have to code everything, but what you need to do is to make sure that the workflow is correct. Where your pumps are, like for example, if you have the tank at home and if you connect the pipe to a different place, it doesn't give water, right? So you have to identify where the data source is and connect it to those places. So from this, you can easily understand it doesn't matter whether it's from iris or not. You can even change this to the data set that you want to analyze. It's automatically put the things for you when you drag and drop. So you have it in the local file system, then files in folder, file, you have all those things, and then read options. Now, since I think some of you have even all of you have attempted Python or C or whatever coding previously, and remember how difficult it was to import and create a data set, maybe a pandas data frame. So you have to look at all those column delimiters and other characters and create a nice pipeline to exclude them and use them, so and so. So here everything is automatically done. You can also go and change it. For example, if your data set has a different delimiter, you can go and change code characters, escape, those things. So I'll not deviate a lot to those avenues because if you take into them, we will lose some time in the future. So when you have time, please explore, try them out. Okay. So we have line breaks, and you can see a visual, some visual of the table that you have imported. So some of you might have heard of the iris dataset. Iris dataset has the 3 different types of iris, some species, some flowers, and it has 50, 50, 50, 150 data. So 50 for each species. So this is how it looks. This Setosa and some other names are there, like versicolor, some names are there. So 50, 50, 50, 150 are there. So then you have these transformations and advanced settings. which we will not discuss here. You can, because it's a general workshop, we will only focus on what we can, do in the short span of time. So once you do that and apply, say okay. So this is your node. This is how a node would look like. And all of you have traveled on the road, right? So the little dots here, they are like that. So it's in the clutch now. So it's like yellow. So once you have put the gear and then put in the gas, it will become yellow, green. So the execution, when you execute it, this will become green. So still the data set is connected, but it's not loaded. Okay. So once you execute it, it will be loaded. So now you can see the table view at the bottom. So this is the complete picture of what you can expect when you connect the node, when you load the data. This is how it looks. You have to the left-hand side all those info and nodes available to be used. And at the bottom, you can see a typical Excel-like table view. And to the right-hand side, there would be other options depending on the node that you take it. There are different colors for the nodes as well. I'll show you in a moment. All right. So this is how it looks. For those who are doing it in their computers, I'll be slow and try to allow you to do it. Okay. So the node is there and the data is loaded, and there's a little tab to the right called statistics. So if you click on this, it will automatically load the statistics for you. So you have minimum, maximum, interquartile range, Q1, Q2, mean, everything is there. So imagine that you have taken some data set for your research, then you can easily look at it, look at all the statistics from there without even doing a thing. Just load the CSV. Okay, right. And there are little things popping here and there. So I'll explain what they are. Okay, so there's a little node like a penguin thing, like you have something like this. And if you just drag and release it, it will show you what it can connect with. Okay? So you have other processing nodes like these yellowish things, and they also have these nodes, little arrows, connectors. So we can actually connect many things like this. A typical workflow will have very complex pipeline. I will show you one. If you have, since I talked about this earlier, since you have the, what you call, use the same link. Since you have the credit risk analysis workflow, just go down a bit to the last pages, perhaps. I think it's somewhere at the bottom. This is an entire workspace developed using KNIME. Where is it? Yes. At the bottom, you should see that node network. Here. So once you develop this, you don't have to touch anything. You just need to execute it like a pipeline. You don't have to go every day connecting pipes, right? Once you fix it, it's there. So this is some other complex net, not largely complex, but this is something like what we want to achieve at the end. So we have a pipeline taking data from multiple sources, connecting, doing the transformation, loading, and then the visualization and saving and all the other things. So the good thing is you just drag and do it. So this is how, at the end, once you do something, this is how your workspace would look like. Okay, right. Now I have dragged and executed my first thing. I have created my data from CSV. Okay. Right. Now that you are familiar with the interface, we have loaded the CSV reader, drag the file directly. We have done that. Manual node addition. This is more, it has more control. So if you go here and type if you know something like, let's say CSV, you have CSV reader and CSV writer. Both. You can just type in any type of a thing, like for example, image. If I type image, you have image view, image reader, some other applications as well. So here from there, you just drag it, drag like that. That is also possible if you are aware of the node that you are working with. Right. We have done this part. Executed. Okay. Execution can also be done. I like shoot method. So you can go to configure. Right. If you right click here, right click, then there is an option called configure. Right. And from there also you can apply OK and execute. I like to click here. It's easy. Right. Let's go to the next part. So I have given you some steps as I go through the, so this is like a monologue, like what I want to tell you and also what you can read on the PDF. Four-based architecture, left to right flow. Okay, that's important. So anybody who can read Arabic? Okay, so you know that the letters are written from right to left, right? So this one is developed by the Western people, so, and we also read from left to right. Because of that, the intuition is from left to right. Okay, whenever you have a process, the in comes from the left-hand side, the out goes from the right-hand side. So it's a left to right flow. That's important because we intuitively think that always it's left to right. Sometimes it's actually, there are some things that goes from right to left, but it's not here. So it's going from left to right. 9 ensures data types are compatible between connected nodes. Also, you have to have minimal consideration when you are dealing with different data types. It will show you whether it's possible or not. Right. So gray nodes, green nodes, and red nodes. Gray, unfigured or unexecuted. Green, as you can see, when the things have happened. Red is when there is a failure. You have individual execution, sequential execution, and partial execution, which means once you have connected that, as I shown you, once you have created that network of things like this, you don't have to do one by one, you can run them all. So it starts from the node and it will just work like a normal workflow, normal water flow to go to the entire nodes that you expect. Right. So Iris dataset, you can also download it from here. I have given you that as a separate file. You can use that. This one also is possible. So I have opened the CSV, dragged it. Here you have to name it. You can name it as you like. Drag it and observe the automatic CSV execute. So data exploration, we have seen 150. If you go through, you can see 150 rows are there, columns are there, 6 columns. So usually, so I may be speaking of what I usually speak, like what we usually tell to the people is that the columns are features. So the columns are features, or you might have heard of attributes. They are all the same. So columns are features. So every column will have the same data type. Every column individually have their own data type, but one feature should have one data type. Okay? So row ID is an identification, then ID is there, then you have the sepal length, sepal width. Those are some measures. They are in centimeters, and you have the number. It's a floating number. You can see number float. And species is a string. It's a category or qualitative variable in statistical terms. So you have the name, right? So that's why it's like that. Right, workflow done. So I have shown you this. Let's move on. Right. So when you have multi-sheet Excel processing, since we have an activity separated for this with the credit risk analysis, I will just come to that when we work with that. So the idea here is that when you are dealing with multiple sheets, Excel sheets, you have an Excel and you have different sheets, but in a CSV, you only have one sheet. when you are dealing with Excel, multiple sheets, you need to create different nodes. And each node will have that particular sheet. There's an option, you can select the sheet. So each node will have different sheets. So that's what it means. Multiple sheets, you have to have multiple nodes. Workflow control and debugging, node reset, node disabling. So those are something that if you into this, you can read and get more idea. Right. Let's go to our now. Basically, think about what is the time now? It's nearly an hour. Say, give or take, we took like 30 minutes. So think about yourself. 30 minutes ago, you didn't know about KNIME, as I heard. So now you are pretty much familiar with it. I mean, that's the beauty of no-code, low-code platforms. You don't have to invest a lot of time on the software itself. You can think about the workflow, right? So now pretty much you understand how to take the data in. Let's go ahead and talk about others. So here we have data manipulation and preparation. So I told you about ETL, exploration, transform, and load. ETL process. That's what the typical data pipeline, how we do things. So most of the time, the data that we get, they are not in the way that we want. Let's go back to the analogy of our water example. So you need a coffee. What you do? You take the water in and boil it and do the coffee process, right? If you need apple juice or some juice, whatever that you need, you have another process, the same water. Think about this in terms of like production line, maybe a coffee shop like barista or someplace. They get the same water like what you get. So if you are doing it in industrial scale, you have a processing pipeline entirely dedicated to do that process. So this is like that. You have the same data set, but you may need a different filtering and different types of processing when you need some other analysis. But you need the same data set to be processed in a different way to get a different output, right? So the row filtering and column filtering and selection, these things happen like that. So this transformation process. So in the case of filtering and sorting data, you have row filtering techniques. So what is the idea behind row filtering and column filtering? So I think it's important that since we are talking about these things, to come to some theoretical things as well. So when you deal with row filtering techniques, what you do is you apply logic. So what you do is basically you select data from features. So you have a feature, inside that you have data points, right? So when you filter, what you do is you ask that particular feature, that particular column, to remove or select certain values. Yes, that's what row filtering is. So when you do that, you inherently follow a logic. It can be something greater than something, less than something, equal to something. So row filtering is always about that logic. So that's how row filtering works. There should be a logic. There should be some sort of a logical sequence to things. And column selection is the other way around. It's a feature selection. So if you delete a column or remove a column, or you process a column, that means you are dealing with the feature and its entire value set. So you can do this interchangeably. Let's say you have a data set with maybe thousands of columns, but you only need 5 columns for your analysis. Then you can drop other 995 columns because you don't need them. So that's column filtering. But let's say you are dealing with some insurance profile, or in a research you are dealing with greater than 60-year-old people, older people. So you have an entire data set. Let's say, let's come to this example of the flood incident recent. So you are dealing with the mental impact of climate change, or mental impact of a disaster on elderly people. So you have a definition that the elderly people are maybe greater than 60 or 65. So you have a data column with all the details and their age, right? But you need only people greater than 60 years of age. So you do the row filtering to get them, and then do the processing from there on that data set, because it's only for them. And then in the same data set, maybe you have a comparison between the teens and the elderly people. you take the same data point node, and then you do another processing saying teens are defined less than 20. So less than 20 and greater than 10. So you have that logic and you do the different process, same process, but for that different set. So it's a subsetting process. Okay. So that's what row filtering and column selection are for. Right. So data sorting, of course, you are familiar with sorting. What we do is from ascending order or descending order, we organize the data. Right. Let's go ahead. So I've explained this joining and combining data also. It means, say you have now you have your credit cards and debit cards and other type of transaction data, right? So joining, in some cases, you have, let's say you have your NIC number or your credit card number. That somewhere else you have another transaction. So joining means connecting the things that are related. So one to one or one to many, many to one, depending on the transaction number of transaction types. So this is just for the understanding. Let's go ahead with our example. So we have, before I go into the micro steps, I'll just give you a brief idea on top. So you have a row filtering step, then you have a column filtering step, then you have data sorting and calculating a column. This is what we call the fancy word feature engineering. So there's a part in the the poster that says feature engineering or something, right? That is for people to get attracted, but it's basically creating new columns. Okay, so creating a column, calculating a column, like we. So I think most of you are from mathematics backgrounds, or you have done A-level combined math, so you have some idea about derivatives, right? Some derivative concepts, like you have, let's say, you have distance and the unit time or unit distance per time. So then you have the velocity. So those are the features. Those are actually feature engineering. So you have, if you have a distance divided by time, without taking the distance and time column, we take the velocity column as our analysis. So that's what basically this is. So calculated columns, petal length divided by sepal length. I don't know why I just took a risk. So then data aggregation. This is something important. The aggregation level. So sometimes what I get from most of my students and people who are dealing with me is that the words. What do you mean by aggregation? So some people find it easy to understand aggregation as like collection of things. So to collect things, when you are dealing with data, you should have some sort of a process. So it can be the aggregation can be summation. Aggregation can be mean. Aggregation can be taking the minimum value out of something. Okay. So it depends on how you define this aggregation process. Usually what we do is taking the sum, taking the mean, taking the standard deviation, some aggregated value. A value to talk about everything. Like if you take one from us, we can be aggregated as a Sri Lankan citizen. So it's one. So one talking about the set. So that's the data aggregation, but that should be a summarization. Aggregation is always a summary. Right, let's create our first workflow. So we have taken the CSV reader. This is our CSV reader. I'll just zoom out. So I like to see things in funny ways. So this is like a bird. So you have this in front. You have the hotter thing, right? You just take it and put it somewhere. That right. Okay. So the next one is the row filter. We start with the row filter. Since I have given you the process, just let's follow that. But it's up to you, whatever you like. So I'll go with row filter. Should be RAW, right? No, it's row means row. We should have row filter here. So you can see there are a lot of things. I mean, I don't know most of it. I haven't worked with them. I don't need them most of the time. So I don't know how they work. Okay. So I'll be honest with you. I only know a few. So if you want to check them out, you can do it by yourself. Just check them out how they work. So I'll just take row filter, not row sample, no rows. A row splitter we will use in machine learning. But for row, this operation, I'll just use row filter. Drag it. Now you can see the stop color, right? The red color. You are not allowed to move. So just drag this and link it. So, it's plain to see it like a horizontal line. So what I do is I like drag it so it's more fancy, right? So those are personal things. Like you can do whatever you like. You can put it up if you like. I put it like down. It's easy to see the flow. So a row filter looks like this. And to the right hand side, you can see what you can do with it. So as I told you, it's a filter criteria. You have the row filter and options to filter. Now it automatically knows what the data is going to be. If you right click and go to configure flow variables, you can see some options there, right? It's easy if you click here. Now, if you click here, now in the previous versions, if you have an older version, most of these things happened by right clicking and going into configure flow variables, because the right hand view, this view was not there earlier for most of these. So now you have it. Now what you need to do is to check it. Now species equals, you can go ahead with the logic. So since I have shared with you earlier that we are dealing with, when we are talking about raw filter, we deal with some logic. It can be an equal, greater than, not equal, whatever. So we are dealing with species is what? Species is what? The data type of species. Qualitative or quantitative? It is a categorical value, it's a qualitative value, right? So because of that, you have this equals, matches, wildcard, all these things relevant to that. Now, if it is a number, for example, like this, you have equal, less than, those operations. Now, if you were to code this, right, maybe from the scratch, you might need to actually check the data. The Python would allow you to do it depending on the data type, but it automatically gives you what to do with it. So we are dealing with the species, I guess. I don't know what I put there. Let's see. We need to filter by Iris setosa. This is the name. I'll just copy this. You have the material with you, just copy it or type it in, otherwise you will not see it. So I'm going to go species equals, and the value is Iris setosa. And don't worry if it doesn't work. You can always do another time. Nobody's going to die. So just apply and execute. If it turns green, it's fine. Okay. So if it the color is green, so it means it has worked. Now check whether it's actually worked. So you had 150. Now in this output, you have 50. I told you it has 50, 50, 50. 3 for different types. So you have 50 here. And notice that the columns have not changed. Okay. So it's just a raw filtering. We have filtered only the, whatever the name, setosa, right? That thing. We have taken Iris setosa data only, equals that, right? The same logic applies to anything. Now, let's go to our next work. It's about column filtering. So this is column filter. The name is there. You just need to put the column, and you have so many those things. Column filter. It's here. Column filter is there. Drag and drop. Nothing to do actually. If you know the process, it's very easy. Then just drag this, and my personal thing, I just make it like that. So column filter, it's in the clutch state. So it's yellow. You haven't executed it. Just check what are the columns that we need to remove here. You have, if once you take in the column filter to the right hand side, you can see a lot of options, either to exclude or either to include. So in this case, everything is included. Check what to be excluded. I think I need to exclude something. Sepal with column. Column filter exclude. Sepal with column. Let's exclude it. Let's go to sepal with. Click on this. And there are a few icons, right? The first, the arrow side, the greater than sign or less than sign thing, the arrow direction indicates where to put it. So if you have double arrows, which means everything will be taken to that side, everything. So I just need sepal width. So I'll just click on sepal width and click on this to put it into the excluding side. Okay. So includes this, exclude this, and just if you are fancy, you can click here or just say apply and exclude. Now you can see the columns have dropped to column 5 columns, right? So you have removed some feature. You can do it any way you like, but I'm just showing you the process. And also you can add a comment of what you have done. So I'll add it. I have removed excluded sepal width. Just put like that. So very similar to any programming where you have the program and then you have comments to say what you have done. You can type in and then the excluded values will be whatever the thing that you have done can be included as a comment. So that's about it. So you have the column filter and you can see what you have done here. There are other options like wildcards, regex, and type. Just please explore them. I'm not going to talk about them in this session. You can try them out depending on what you have. I've requested you to bring some data set if you have. If you don't find time here, you can do it by your own. Just try to explore it. And I actually, I usually market these things for the people because they are free, and for people like us in Sri Lanka, it's very useful because they are free and you can use them without any payment, or it's very useful in that sense. Right. Now, let's go to the next one for the sorting. So the sorter node is also there. It's easy to remember. When you type in sorter, you can see this little arrow thing, and you can go to sorter, drag it. Let's take it down and connect it. So I feel it like there's a water flowing. So there's a sorter option, what to do with it. So you have a criterion either to go with ID. So there's an important thing here. Now let's go back to the same example about flood affected elderly people, something like that. So let's say that you need to sort them maybe by their age, maybe by their income level, maybe by their other things. So you can actually go and add the sorting criterion here as well. So it's like this. You sort them first based on something. After that, you can sort based on the other thing. So let's say you order them according to their age first, and then you can go to maybe their name, something like that, okay? Depending on what you need. So I'll go ahead with what is my requirement here. Descending order for the petal width. Is it sepal length? Descending order sepal length. So I'll just select sepal length. Now I don't have my previously removed one. I have sepal length. Click on this, descending order, and execute. Now you have the descending order. The largest value will be at the top, and it will go down gradually. So that's descending order, sepal, whatever, sepal length, largest to the smallest. Right. The sorting has been done. Now see, even if you just save it like this, next time you don't have to go through any coding. It's very simple. You just see how it works. Right. Then feature engineering part, calculated column. We'll create a new column using the math formula. So there is a formula node. Everything is a node here. So everything works as a node. Let's go to math formula node. If you type in math in the node explorer, math, there are a lot of math formula variable like dy by dx things are there. Some other options are there, but I'm not going to talk about them. But I'll just go with math formula, simple math formula. Click and drag. Okay, again, it's good practice to put what you have done here. So what did we do? So we descending order sepal length. always keep it as a practice, even though I haven't mentioned it in this handout, to mention what you have done. Because maybe after 2 weeks, you don't remember what is 9. Right? So that level of memory is there. So when you at least remember 9 when you have done something, then you come back at least check what you have done with the comments. Okay. So math formula, we'll go to the dialog and see what, okay, we need to connect it, connect this, drag it down. Now, once you connect the data, it'll open up this nice window. It has all sort of math options. Like you have, if you are into analytics, you can look at many other options available here, right? You have the log transformations, inverse log, tan, cos, all those things are there. So pretty much like any programming language, you can do whatever you want, but drag and drop. So what my option here is to create a new column, feature engineering. I'm going to use petal length. So let's see what I get. So I have petal length here. If I click on this and double click, it will come to this little expression window with dollar marks. So whenever you are referring to a feature, it should be a dollar with inside dollar marks. So petal length is that, then like a usual math operation, I'm going to divide the petal length by sepal length. I don't know why I have done it, but I'll divide it by sepal length with double click it. So the operation is there, right? Okay, now here's an interesting thing. So now I have done a division, right? So let's say you have 0 length values. Let's say you have some undefined values that are not supported by division, maybe matrix operations or something. So that's why you need those other operations early on. You need to know about your data. So if you know about your data, first thing you can do is you can remove them. Otherwise, also here you will get data with those errors, like not errors, maybe infinite values. So some other operations with those values. So when you're creating the pipeline, it's like you don't, if you want to make a coffee, you don't boil the tap line first, right? You have to take water and then boil. So don't do operations here and there. Just know what your thing is. So we'll be creating it as a new column, append a new column. That's what we call feature engineering. So I'm going to create petal sepal length ratio as a new column. So I'm going to add a new column, Control V, apply. Now it's ready. Now it's in the yellow light. So I'm going to push it. And now, as you can see, the petal ratio is there. It's a very simple calculation, but you can think of many other things you can do with it. You can, if you have an, say, mathematical model that you want to test, you can type that model here in the math formula. If you want some other operations, you can do them, right? That's basically the flow. So since we will be going for a break, I will the sorter and then this is there. Right. I'll do the group by as well. Okay. Now, what do you mean by group by? The group by operation is actually used for aggregations. So what do you mean by aggregations? Let's say I need a particular qualitative label. Let's say this versicolor or whatever the names that we have. Then I need to aggregate a value to represent those labels. Say, for example, I need to know, say you have a lot of students at University of Monaco. So let's say I need to, there are different faculties, I think six faculties, right? So you have Archi, engineering, business faculty, and then IT and medicine. So let's say, what is the average height of a student, a male student in a faculty? So that's aggregation. That's group by. So we group by the faculty and the gender. So first by the faculty, by the gender. Or first by gender. If you first group by the gender, can you group by the faculty? you need to then find another rule, males of the faculty, because the superset and the subset are different. So male and female both will be inside the faculty. So if you first group them by the faculty, then you have the two male female options to take the second group. But if you start with male female, that cluster is large. So then you have to go with another label to divide them by different faculty. So that's the difference between a workflow, the data pipeline. Okay. So as I told you, now here group by works like that will be grouping by, I don't know what it is. So let's say average petal length by species, creating a summary table. So we will first start with now the math operation is there, which does that ratio thing. Let's go with a group by. So type in group by. It will only take 2-3 minutes. Group by. Type group by. You have I like this one because it has a lot of creative graphics. So you have this thing. You can understand how a group by would work. You collect things and put them in. Just connect it. Open the dialog, and now you have what to group by. So I group by the species, and the manual aggregation, I can aggregate it manually. So the aggregation happens from groups, species, that's the group. Aggregation, the numerical aggregation is from sepal length. So I'll just take the sepal length and then add it, and then it asks me what is the aggregation that I want, whether it's the mean, whether some other things are there. Depends on what you need. Okay, and then just say apply, and okay, execute. And you can see, because it's only having iris setosa, as by this point we have removed other things, right? We are only 50 here. By the removing of the raw filter, we have only one species. Remember? Because by the raw filter, we took only one. And because of that, the group by will only show one species. It's there only one type of species. Okay. Okay. So far I have gone very slowly. So I'll now go very fast. Okay. So now you understand the basics of the visualization and how to connect the nodes and all. So the next stage is actually doing something with this. Okay. So if you go to the handout, so far what we did was we aggregated the data. We started this process, but we didn't go to the exploratory data analysis part. So, but with the group by option, group by node, we did some analysis like that. Okay, so I'll show you two things about this workflow. Now, as you can see here, when I group by, since I have excluded the other by using the filter, since I have excluded them, I haven't got the full species or group by functionality because I have removed it. Now, if you want to go ahead and change it, you can go to the raw filter, and now you can do many things from here. It's like changing a valve from the top. So you can go to the raw filter, and then maybe you can exclude equals and then not equal. Let's see what will happen. Now I'm changing a valve from somewhere at the upstream. Okay, so if I change the logic here, species not equal, what will happen? There are 150 data points. So when I say not equal to this particular thing, I'm going to get all the things except whatever iris setosa is. Okay, so when I run this, when I apply and execute, you can notice that all the other things became yellow, right? Because the workflow now depends on the previous work. So if I go and execute them, you can do the same operation, but now notice when you go to group by, except that particular thing that we exclude, other things would be there in the group by. Okay. So likewise, you can do many such operations. The other way around is, if you want to look at them like in different facets, you can add other nodes as well. For example, you can add different nodes. Now I have a row filter here. I am going to create another row filter, right? Sorry. So previously the row filter was connected from here and I excluded the value here from my logic. I can now create a different workflow with my row filter. So you can likewise create many arms of such such workflows, right? So now instead of the row filter logic here, I can use a different row filter logic, and then I can also check the same thing from here onwards. So that is the beauty of this. You can create many networks of different analysis. Okay, so I'll just delete this. Let's quickly go through the handout. Okay, so statistics, I believe everyone is familiar with it, but no one knows it fully. So so in terms of statistics, we usually use, let's say, for example, if you're in a decision-making position, you might need to know the mean value, the standard deviation, or Q1, Q2, Q3, those kind of very basic values. But if you are doing an analysis like hypothesis testing or something, you might need a different set of things. So I'm not going to talk about core statistics, but exploratory data analysis means taking the basic statistics into equation. So I'll talk about the essential visualization types as well: bar charts, pie charts, histograms, scatter plots, line charts, box plots, those things. So we'll start with a simple EDA application. To solidify this understanding, we'll go with summary statistics. So you have already done statistics node. Just type in statistics and you can see this little thing with I see this like a tank, like a war tank. Just take this. So take the statistics node in, and you can connect the data sets you have. Do we have the data sets? I'll just go through a data set that I have already. So I'll just plug in this. Now see, you can connect again to the analogy that I talked about early on. Think about your water supply at home. So if you need a new supply, maybe you're doing the gardening part, then you need a different water supply there. What you can do is you cut the pipe and connect a T section or something, add it. So I'm going to use this column filter and I'm going to add it to statistics. Now statistics will take this part of the water supply, row filter, column filter, and whatever the data spit out from here. That's it. And once you run it, you can go to the dialog and check what are the things that you need. Like you can go to exclude and include. So I will go ahead and remove something and maybe sepal length, petal length, and say apply. Okay. And now if I execute it, now you can see the statistics. Previously also you can see statistics. Now if you go to column filter and go to statistics, you can see it, but that's a function that's available there in the feature. But if you go to the statistics, you get an entire set of data calculated based on the statistics that you want. And there are other nodes coming out of it. See, statistics table, rows and columns are there, and other tables. So you can do many things with this, like for example, if you want to say statistics view, take a statistics view here, connect a node that comes out of it. It doesn't give me that, right? So yeah, if I connect directly from the data, this statistics, I just take it directly from the data. And if I include, for example, sepal length, petal width, and maybe species and run it. Now you have the statistics view, some view of your data. And this table is also interactive. You can play with it. You can, if you have a large data set, you can easily look at the values. For example, 75% quantile, 50% quantile, and all those data points that you need here. So basically, you create your own program, but based on the nodes. Organize nodes accordingly. That's what you do. Let me show you a very interesting thing now. So in our I'll not go into this relationships stuff here, but I will go to this one because this one takes some time to digest, and this will be very useful. Okay, so publication quality figures. Most of the time, what we suffer from is we do an analysis, but how do we take it up a notch so we can publish it? And I think that's a major issue that most of us face. So, I mean, learning about analytics and doing analytics can be specific to your own task, but at the end, all of us will have the same problem, how to put it into publication level quality figures, right? So I don't say, there are specific software built for this. Now, for example, if you look at Prism, so there's something called Prism. This is very good for 2D visualization, Prism, graph Prism, this one. This one is very good for publication quality figures. Now, if you are, for example, doing your thesis and you are in the last phase of your thesis and you would like to have some quality figures, you can go and purchase this, but it's not very expensive. I think for day or two also you can purchase the license. For example, there is a free trial version as well. If you go to academic, there used to be a student annual student version. You can here $50 per month. This may be very useful if you have a trial and you sort of get an idea of what you need, and then $50 per month. You can have an entire month of this monthly subscription, and this is very useful because it has all those nitty-gritty things that you might need in a publication level figure. Like, for example, the line thickness, the font, the tick size, the labeling, to integrate some figures to that. So those kind of things are here with the Prism. So I'm not going to talk about that in detail. And also you have Orange software as well for data mining, but I'm not going to talk about that either. But so why I shared that one with you is because here I'm not going to give you like one medicine for all kind of a thing. Okay. Here, what I'm going to share with you is something that you can do with 9. And then you can, of course, take it into a combination of figures. You can use PowerPoint, you can use Inkspace. So since this is about data visualization, I'll share that one as well. There's something called Inkspace. So Inkscape. This one. This one is also a free software, pretty similar to Adobe Illustrator. You can combine multiple figures, and also you can set the DPIs, set the quality of the exports. You can do that from here. So let's say you have created multiple figures from different sources. You can connect them and organize them here using this. It's free, so you don't have to worry about paying also. And of course, the last resort is using PowerPoint. You can connect the things in PowerPoint. But the problem is you can't change the DPIs or the quality of the figures. Usually, if you have submitted the journal paper, you know that the requirement will be around, you need one. I usually prepare figures around 1200 DPI, because if you have simple, very fine details, it's easy to see. But usually the requirement is around 700 DPI. They'll require you to adjust the figures accordingly. So don't wait until you hear this from the journal. So you prepare the thing, everything, and then it goes through the desk acceptance and then the reviewer comments, and then you get it published, and then suddenly the publication department asks you to get better figures. And that could also happen. Maybe you are in the mood that your paper is accepted and you are so happy, but then suddenly the happiness curve goes down because you have to prepare it very quickly. So don't wait until the end. Prepare your figures early on. When you are developing the paper itself, build the figures into that quality. That is more important than actually doing it at the last point, because it will be very difficult, right? So whenever you are developing a figure, try to develop a figure greater than 700 dpi with fonts. Maybe there is no recipe for all, but it depends on the style that you have in your mind. And keep a piece of a paper or some note and discuss with your supervisor and people who are working with you, so that everyone is on the same page. Put maybe like line sizes, maybe 1 point line, 2 point for the board, 1 point for the border, 1.5 for the line, tick size, the colors. What sort of colors are you going to choose? Blind, say colorblind people are there. What sort of contrast that you are looking at when you are printing it in a grayscale image, whether the colors that you put will have a contrast, right? Think about all these things when you are developing. That is philosophy that you have to have when you are developing figures. So I took this opportunity to share this with you, because most of the time what we expect is, why do we do research? We do research, one thing, of course, for our own realization, but the most important thing is for publications. That's the most important thing, because you do something so that others can use your work and build their own things. That's what we say, standing on the shoulders of the giants, right? So that's what we call citations. Not that your friend is there and I'm going to cite his work because he's my friend. That's not the model that we should be going at. We should be developing something so that others can use it. That is the gap in research that we search. Okay, so most of the time when you are doing the literature reviews and when we ask you to find a gap in research, or when even us trying to find the gap in research, we try to read it and find something that we want, right? Those type of things are useful if you are dealing with a large scale problem and you have a vision for it. Okay, so sometimes there can be a large scale problem that you envision that there will be in another 50 years, then you try to solve it. So there is a vision. You develop a gap inside of your work. But when you are in the early career stage or as young researchers, the best would be to see what the others are demanding. If you read, that's why you are reading others' papers. So when you are reading, sometimes they are saying for the future directions that this thing is lacking, or such model has, look at the methodology. Sometimes they say we took this data set because there are not enough data in this area, right? Then sometimes there are a lot of assumptions in the research saying that this curve, we assume the linearity, we assume the non-linearity of these things, or the data would look like this and that. So those are the requirement of the others, the peers. So if you can build something for that requirement, then you are actually in the game. So because you are trying to build something that others want, then others will have value in your research. So all in all, the idea is, one thing, you need to do research that are accepted by the others or needed by the others. The next thing is, when you do something, say, so all of you would agree with me, if you go to some posh restaurant or something, there is a feel for that, right? With the logos and the colors and maybe the old newspapers on the wall, like to show some classic stuff. So likewise, research paper would also be looked at with the visualizations. So the figures that you make, English and the writing would come later. First, if you go through a paper and it's very messy, you will not, you have a natural tendency to not trust that institution or the people who have done it. Because you can't really say, like, if it looks nice, if it has that professional quality, then you tend to feel that, okay, these people are serious. They are doing it for others, like some feel is there. So when you are developing figures, always think that your figures will be observed by others. So make sure that it's easy for them to follow, not for you. Okay, so that's why you need to have some motto and some idea of what you are doing and the message that you want to give, right? So that in mind, let me go to the visualization section here. So we have statistics view. If you want a histogram, for instance, just type in histogram, and there will be several histogram options: interactive histogram, histogram. So I have done work with the histogram earlier, so I'm happy with that. I just take histogram, and I can easily take whatever the output that I have from there and connect it. So my histogram would look like this, right? And here you have the data filtering part, binning part. I'm not going into the details of statistics, but you should know about what you are doing. So equal width means the difference between the starting point and the ending point of a pillar starts from there. If it is equal frequency, you give some equal frequency value. It depends on what you need. Now here, the dimension, the value is, let's say I'm going to use sepal length, for example, and then apply and execute. Apply and execute. Now you get it. Now you can open it in new window. You have the histogram, right? So this is one way of just taking visualizations at your will. And this is, so as I told you, research papers are built, the final paper is like the performance. The last part that you see on Elsevier or Nature or wherever, that's the final act, right? Before that, you need a lot of refinements. Like, again, I told you, now I'm going to contradict myself. I told you to build figures in the publication quality at the very starting point. But that being said, you also have to have this idea that you need some sketch to work on. So this is that. You look at the visualization, you look at the, and say, okay, now in my opinion, you have a higher frequency during or in between 6.25, 6.4. Then you can go back and do the analysis and see how this looks like. And if you're happy with that, then you go to the final visualization or the creation of the figures, right? So it's a back and forth process. You have to work around that. So let's say I'm going to go with the equal frequency, for example, then you can look at how it would look. This is not, trying to fool someone. This is just to make sure that whatever you try to share with others is easy for that person to read, that person to understand. It's not changing data or anything. You try to give that punch. So let's say, for example, if you are trying to talk about this particular thing and you notice that the frequency is higher as compared to other things in this range. So if this is what you need, you try to, if this is a significant finding that is relevant to your work, you try to highlight this in your visualization. So that's what basically a good visualization, publication quality visualization means. Right. So that's histogram. You can go ahead with a bar chart as well. So there are bar charts. Take the same thing, just drag it, and you can go with category dimension. Category dimension is species in my case. So I can go with the occurrence count as the aggregation, the number. So the bar height will be the species height, number of species. And also you can select the bar chart type. And at the bottom, you have something called generate image. If you go down, I didn't see that in the histogram. Yeah, there's an option called generate image. In most of these visual nodes, you have something called generate image at the bottom here. If you tick this on, right, you would see something at the end. So you have, when you tick it on, you have either to save it as a PNG or SVG type of the quality of the figure, the number of pixels and all. So you can say apply and execute, and you can see this little green square appearing at the end. This means the image is ready. Output image is ready. It's not saved yet, right? So whenever you see this like kind of a green thing, it means something is ready that can be taken. But you have to connect it to another thing to write the image, but the image is ready. So you look at the species, Now you can easily see it's equal because the number of species is the same, 50-50, the count is 50, right? So now I'll show you how to save this bar chart. Say you need to save this bar chart. Now, if you forget how to do it, just click on, now remember that you need an image. So generate image is there. But once you get this one, just drag and put it in the empty space, and it will ask you what to do with it. How would you like to take this image? So I would say image write a port. Click on this, and now it will be there. Image write a port means there's a node that write your image in your disk. So if you double click on this, you have the file path. Just give the file path wherever you need. For example, I will just browse to my folder. Yeah. I will just save it like bar chart. So let me just save it. Now it's SVG because I think I have put SVG there. Okay. And then run it. And you should be able to see it in the folder that you created. Bar chart, SVG. I can't open SVG here as I remember. Let's see. Yeah, it's not opening. I will change this to PNG. PNG is there. I will change this to PNG. And then run it. Should be able to see, yeah, bar chart. So this is very good to evade your supervisor. Just take some time and then show. Take another week off. So you have developed a figure, right? This is good. I mean, in terms of a general discussion, to discuss about your findings, to brainstorm, and also to have a good go at it. This is good. This is more than enough for a discussion, draft paper. But then you have to work on how would you develop this figure, right? So in order to develop, you need to have more control over it, right? So how to change the colors, how to change these other things. So some nodes would give you that option. Some, for example, if you go down here, sometimes they will give, now here it's just the size of the image, right? So you don't get that option. Most of the time, you don't get that option in 9 because it's more of a workflow based software. That was the reason, like most of the researchers might not have used it early on, even though it has a lot of powerful integrations. So that now there's a way around. So the way around is there's a Python integration that allows you to do this. So there's this Python thing. So now what you can do is you don't need to know a lot of Python to do the processing and all. What you can do is use Python to create that final visualization. That is very useful. So I'll show you how to do it in the handout. If you go down, there is an integration. I'll start with that. So I gave you the need. Why this Python integration was needed. Not Python, there are a lot of other integrations as well. I use Python because it's easy to work on it. So this is there. And let's say, how do we integrate it? Excellent native visualization, integrating Python unlocks unlimited possibilities. Now, all of you are familiar with AI tools like ChatGPT, Claude, or Gemini, and they write very good codes, right? So what you need to know, what you need to do is to make sure your variables, what are your variables, and create a block code for your visualization. And to do that, you need to have, as I told you, a handbook of what you need. So it can be the font, the point size, the font color, the coloring, what you need. So give that prompt to the AI tool, and it will give you back a code, some code that you can use with whatever you do. So you can have that and then integrate it with the Python extension. So how to do that? First of all, you need to install an extension. As I told you, this one was developed in 2022 or something. So how do we integrate this? You have 9 extensions and search for 9 Python integration. You can go ahead to your Python, and if you click on menu, install extensions. So these 3 dots, menu, install extensions. Click on this, and it will open a window like this. Right? There are a lot of extensions available, big data extensions, a lot of bioinformatics, chemistry, image processing. So that's why I recommend this for you. You have multiple types of research. You are working in different areas. So extensions are there already. You can use them for your work. And also, I think some of you are working in the qualitative domain as well. Probably you can find whatever you like in the extension. Just search for it and search for the communities. There are a lot of things being built. So here I need Python. Right. So you have a lot of geospatial analytics extension is there. Python extensions are there. Now, in my case, I think I have installed it. Because of that, I may not be able to see it. But if you search this on the search, yeah, because it's, yeah, here. I don't see it because I have only installed. You should see it. I have installed this. Because of that, I can't see it here as an available software. It's there, already installed. See, I have installed it. 9 Python integration, 9 Python build Python environment. This is useful. I'll tell you why this is useful. So a lot of whys are there. I'll explain why as well. Right. So how many of you have worked with Python? Can you raise your hands? Okay. So how many of you work with Anaconda and VS Code? Anaconda. I asked. So Anaconda, please. And VS Code. Okay. Right. So you know how hard it is to install the data science modules, right? So for example, there are a lot of module incompatibilities. Like for example, if you use geospatial integrations, sometimes let's say one matplotlib 4.1 might not be responding to another module. Let's say GeoPandas is not responding to pandas. There is one type of thing, the other type of thing is not responding. So again, Python versions are there. So sometimes Python version 4.3, like there's 9 now, Python 3.11, 3.12. So sometimes some modules are written in those Python languages. So you create a nice workflow, and then if there is a new update, sometimes your work might not be executing as you expected because the versions are not compatible. So what you need to do is developing virtual environments. So that's why we create those virtual environments before we start any coding work. We create a virtual environment, we put everything into that virtual environment and activate it and then work. So those who have worked with Python know this process, right? So with this one, you don't have to worry about that, because the integration, the Python integration itself will have all those modules required. They will be pre-bundled. So the version incompatibilities will not be there, right? So once you integrate the Python integration here, how many of you are able to do that integration? If you have already downloaded and if you are working here, check whether you can do it. Once you integrate it, you would see that once you installed and integrate that extension, go to your preference, and then you will see Python here. Once you install Python integration. Then you go to preferences and you would see Python here, Python in the preferences. So in the Python, when you click on this, there would be that same issue, like either to use the Python from the bundled version or from the Conda environment or manual thing, right? So since you're not familiar with anything related to connectivity, just go with the bundle. That is the recommended version, because there you don't have any incompatibility issues. This is developed directly for 9. So go with bundled environment, bundled connection. So then that issue will not be there, right? So that is done. Now let's go ahead and do some work with Python integration. So bundled environment is done. 9 will auto detect bundle Python. So bundled environment requires no additional package installation. That's what I explained, right? 9 Python integration, bundled, done. Right. So there are 2 nodes that would be useful for you. The first one is Python view node. If you type in Python view, this is Python view. Then there is Python view legacy. Then Python script. These are the 3 things that will be useful. I'm going to use Python view. Just drag and drop it. Right. Now, since it's a bundled version, once you drag the node, the required code will be here. Matplotlib, pyplot, those things will be imported. NumPy as NP. So what happens is, when you use the CSV reader, the CSV reader takes in the data to 9, and it needs to be created as a pandas data frame. So this code is built for that. So for example, if I go ahead and double click on this, you can see the Python code here. So you have 9 integration, and then import NumPy, that is number Python, then matplotlib, that is for the visualization. Then you take the data as a pandas data frame. So this is what the usual workflow is. So once you drag it, this is how it looks like, Python view. So I have given you some codes here. So don't go into the details right now, it's not needed. So let's go with this Python reader view integration. So I have taken and I have given you some codes, right? In a usual day, I would ask you to work with this because you can't copy paste it. When you copy it, the entire thing will be copied, so you have to type. Let's go with the codes. I have shared the codes with you in the folder. In this folder, so you have the code. Let's start with the code that is required. What is this correlation code? Yeah, correlation metrics code. So just observe the code. I'm not going to go into the details, but for those who are familiar with Python, I'll just explain. So you have the KNIME integration, matplotlib, that is the plotting function of Python. Seaborn is the data visualization package in Python. Then you have the reading of the pandas, and then that's all. So just Control A, Control C, that's what we do usually. So we go to the Python integration, Python view. I'll minimize this. So this is the Python view. Okay. So you can just copy paste it here. So I'll just enlarge the view so that you can see. Control A, delete, Control V. Okay. So the code is there. So I have built the code specifically for this. So now let's just to get an idea, what I have done is numerical columns. I have created a data list, and then numeric data will be the data in that numerical columns, and then the correlation will be developed using that. So I told you, when you are dealing with programming languages, always you have to create that workflow clearly, right? Then just minimize this, and let's see what will be there. So I'm going to execute this one. So now you can see the visual. So this is publication quality visual. So you can change this inside Python. You don't need to know Python. You don't need to know how to create virtual environments. You don't need to worry about the integrations, all the version updates. You don't have to worry anything. Go to your chat GPT or whatever, ask the development of the code and understand how the code works, a simple workflow, and then paste it. So you can get the Python view directly from here. So it's very unique and easy to follow. And what it has done is it has created a correlation matrix of the values. That's one exercise. I'll just type in what we have done. So close this. So what we did was correlation of iris features. And it has a comment. Right? Done. Just drag it like that. It looks like a serpent. Right. So I'm going to get another Python view. Take it. And I'm going to take the same CSV reader, put it in, and it will open up the same code that you saw last time. Whenever you take a Python view, that's how it looks like. So let's go to the coding. I'll explain. So the next coding is about, okay, I'll come to the image writer part in a moment. But now let's go to the ridge plot for distribution analysis. So how many of you have seen ridge plots? In research papers, have you seen ridge plots? What is a ridge plot? Okay, I'll show you what ridge plot is. So let's go to what is this distribution, petal length distribution. So this is a ridge plot. This is ridge plot. What is a ridge? What is a ridge? Ridge. Ridge is something like this. Like a small mountain kind of a bump. So ridge plot means you have ridge as a plot. So what it does is it allows you to check for the mean or the center of the data distribution, how they have changed. Now, for example, iris setosa, when you look at this, it's a narrow distribution with a mean closer to its distribution. But here, the spread is there for the versicolor, and then the virginica, there's a spread, and also the flat top is there, and you can see the if you draw a center line here, they are closer, and this one is further from them. So just by looking at this, what can you infer about the data set? Now we are doing data visualization. It's not just art, there is science as well. So what can you infer from this? So you need to build this idea, like just looking at the data, you should be able to map what the actual thing is. Now, in terms of the petal length, the versicolor and virginica, they are close. So if you see a shorter petal length, there is a high chance that it is coming from setosa. So that is what the inference or what you infer from a research paper or a figure. So now, if there are if you see something like a larger version, or you need to know the mean distribution of this as well. But if you have a value somewhere closer to greater than this one, you can infer that particular value belongs to more towards the versicolor or virginica. And if you find something contradicting to this, that's where real science comes. So you know there is an issue, you hypothesize something, and then you try to see what that hypothesis is, whether there are supporting evidence to negate or support that particular hypothesis, right? So let's go ahead and develop this this distribution plot. So this is, I think, distribution. So this is also there in the text that I shared with you. Just take it and paste it. Control A, Control V. And I'm going to minimize this or run all. And I minimize this. I'll execute it here. So, right, see. It's developed. So now the good thing with this one is that once you develop this code, right, you can change it. For example, if I want to change the colors here, the colors are there. I can change the colors. I can customize it. I can, if I want, I can change the figure size of it. So you can think about the publication, the totality of the figure that you want. So always have some idea. So how many of you have seen postcards? So people used to write postcards and send it. Have you seen there's a block in the postcard? So there's a small stamp block and then the address block like. So think about a figure when you're developing a visualization like that. So what is the major block that you want and how big you want each other blocks to have? So the good thing is you observe research papers with high quality figures. Maybe you can find them nature biology, nature, Elsevier in some cases. Don't follow like now. So once you click on, you can see this green square, something that's popping out from it. This means you can actually get that image port. So image right above, click on this. Now whatever you have created, you can save it. It's very easy. So just give the file name that the extension that you want, go to your folder, give the name, and it will paste, it will create the folder for, sorry, the image for you. So I'm going to go for documents, my folder. Sorry. How do I go back? Yeah. Right. I'm going to save it like, let's say, what is it? Rich distribution or something. And I'm going to save it. And it's going to be saved as SVG. I don't have SVG reader here. I'll just say PNG, apply, and OK. And then run it. So you can see once I request the image to be developed from here, it will be automatically asking the Python view to create it. So you saw when I connected it, it was there in the yellow icon. Now it's green. So the image port should have worked by now, and I have this one. So this is publication called figure. You can change this. You can do whatever you like inside Python, and that will be creating the figure from there. Right. Let's look at other things that we can do with it. That is a very nice thing. Let me show you that as well. So Python script. So this is not for publication, something. Oh, thanks. Right. So nowadays people would like to have 3D visualizations, right? So let's look at this. This is going to be an interesting thing. So I will create a 3D visualization, interactive 3D scatter plot. Let me show you this. This is very nice. Can see. So now instead of Python view, I'm going to use Python script. This is Python script. Let's take it and connect the data source to that. So this is my Python script. So I'm going to paste it and I'll explain what this is. So what I'm going to do is I'm going to create scatter plots, 3D scatter plots using XYZ columns, XYZ axis. X will be sepal length, Y will be sepal width, Z will be petal length, right? Then the color based on the species. And because it's a qualitative column, right? I know them. So I know you have to know them when you are doing it. So you develop this and just run it. Okay, the issue is because I haven't given the file path here, your file path. So I'm going to give my file path from the folder that I am working on. So it will be from users somewhere here. I'm going to paste it. Right. So this is my file path. Now it should work, and it will be a 3D plot HTML. Right. It's saved successfully. Let me show you what it is. So it should iris 3D plot HTML here. When I double click, you will see something like this. So this is an HTML and it is interactive. So you can go through this, right? And then the details will be there. Remember what we understood from our ridge plots. Remember they are further away when it comes to the petal length, right? So you can see this. This one is away from that in terms of the petal length. So you can actually play with this. Play doesn't mean that you can play like that, but you can go for orbital rotation. I like this. You can look at your data from multiple angles, right? How you would like to see them. And in general, a figure like this is very useful to understand that hidden meanings in the data. For example, this red color thing, it is iris versicolor. What can you infer from this? Typically, if you look at this data, it's always at a center point, like it's like the middle character of these two. If you think about these three species, this is the middle character, sort of. I mean, when you create these type of images, they give you very nice visuals and interactive visuals for you to analyze them. And you can do them, I mean, using Python or R or anything like that. But the beauty of this is you don't spend valuable time on learning those things, like trying to set up all the other things, the dependencies and all the other things. But you can use the power of their integrations directly inside KNIME. So this is a 3D plot of that. Let's go to the next one. Let's go to Python script is there. Okay, I tell you why I have used Python script here. There's something called Kaleido. Yeah, Kaleido extension. I can use Python view here as well, but I need to install Kaleido. I just minimize the number of installations that I need to do. Because of that, I use Python script and created an HTML extension, HTML file. That's what I did. I like this one because this one is more like sciencey, right? You see these kind of things in science papers most of the time. So it's not that difficult. What you do is you go to Python view. So I'm going to create my next. Zoom is on my way. Right. So I'm going to drag this. This looks like a real serpent. So I'm going to take my next Python view. By the way, you can do all these things in other Python views as well. I'm just taking them so that they are separate. You can see them when you want separately. So Python view, and this is going to be my next one, next code. So it's already coded. That is iris box plot, this one. I'm going to just copy it and paste it here, Python view. Let's run it. So the console is there, it will show you everything. And once you get used to it, it's not that difficult. I can make it very complex, but I'm not making it complex so that you can also get an idea of it. So once you make that Python view, you can see it like this. And like we did last time, you just get an image writer port and save it to somewhere of your interest. So read through the code and you can see where to change, what to change in the code. And then you can easily create your colors, create your icon sizes, the size of the things. So you can actually meet publication quality standards with a free software. So that's one plus point that I see. And also the analysis. So in the interest of time, I will not touch upon other machine learning related tasks and other things, but I have shared with you the second handout which contains the machine learning part, but I will just try to go through the handout at the bottom. So try to do this one as well. It will give you a radar plot, the next code, and that will interactive parallel coordinates. This is very nice. I think I have created it in my folder. Oh, I have to go to the folder. Yes. Right. The other one, yeah, this one is that final code. It has to be somewhere here. Radar plot. Okay, I haven't created the text file. I've forgotten it. But you just copy paste the code there, and it will work. So once you copy paste the code here, it will create this. And once you get this one, I think I can now show it. I created it. This one, no. Okay, I forgot to save it, I think. So yeah, just go through it and run it, it will work. So this will give you a figure like that, and it will not be that difficult for you. You can, so this is pretty much what you see in papers, right? So you have this type of figures. You can create the figures, save them separately, combine them in a software like Inkscape or PowerPoint or whatever, and combine the visualizations. So I have completed this part. The other part, so I'll just go through it. So what it does is, this one is a data set from a bank, not a bank in Sri Lanka, but the bank has credit cards, right? Credit card offers, not offers, credit cards, giving credit cards to people. So they have profiles, the previous owners or people who have used credit cards from the bank, and they have details about their past usage, how whether they were they were paying credits on time, whether they have this and that. So their profile is there. So what this will give you is, it will create a machine learning workflow to identify and predict, if you take a customer, whether that person is going to default or pay the credit card. So that's the idea of this one. It has all graphical nodes and everything. I use this for teaching, so you can follow. It is not that complicated. You know the process already. Anything that you might find challenging would be there in the machine learning literature, which is maybe why you have 70-30 separation, what is confusion matrix. Those things might be there, but all in all, if you run this one, you will get a good idea about how to do machine learning tasks as well. So you hear these decision trees, for decision trees and random forest and all these things. Those things are here in the 9 workflow. Once you get familiar with it, just go ahead, go forward and do them using 9. That will save you a lot of time and frustration on coding, because it's a no-code environment. You can get a lot of things done. And all these things are graphically shown here in the handout. So if you try to do this, you will find each and every step easy to follow on this. So that will conclude the session, right? So if you have any questions regarding this, I can spare 1 minute. So what is it? Okay, just to have a feedback, live feedback. So raise of hands if you find this thing useful. because I'm here and I did it. You are raising hands, right? But the important thing is like you need to practice this, right? If you want to use it, I encourage you to use it because it's free. Countries like us, we should not be promoting things that are expensive. And if things can be done with minimal expenditure, then we can actually do them with the professional quality. The same quality is there. But what we need to do is we need to find workarounds. So if you are willing to use it, please use it. That will be my take-home message. So, okay, participants have raised hands. I mean, for the raising hand that I asked. Actually. Okay, thank you. Yes. Yeah. Yeah.
I mean, like, we have downloading something from the
Yeah.
CSV file. And we upload it to box here.
Yeah.
Sometimes CSV file doesn't work if we file that open it and do some changes.
Yes.
No.
No. This is directly, it will take, you have option to change whatever the number of lines you are going to read and all these things are there. Just check them out. It's not like that. In the VOS viewer, what you do is most of the time, if you go and check, sometimes you have unintentionally put an enter. So there is an opening at the last line. Sometimes it is difficult for the program to read it. Those type of things are there. If you filter data, remove the data, check the encoding has changed. That's why sometimes this error comes in VOS and other software mainly. So, for example, I intentionally did something here. If you check it, this is extra time, right? So when you go ahead and check these codes, if you notice, I have stopped it at 51. Not because it's going to do any error here, because sometimes if you put an enter line here, in some programs, the empty line at the end might be an issue. Some cases, I'm not saying here, not here. I haven't noticed it in 9, but in some cases I have seen if you have extra spacing, extra different characters, that can be an issue. Okay. Any question? Okay. Before the questions come, I'm going to leave. Right. Thank you. Thank you for your participation, and I hope it's useful.
Indeed, it was a useful session, sir. Thank you very much once again, Dr. Dasanayake, for that incredibly informative and engaging session. And for sure, I know that everyone's publications will be more colorful in the coming years, and looking forward to seeing such wonderful publications as well, as I mentioned. So it is now time to express our sincere gratitude to our resource person today. And I would now like to invite Dr. Ashwini Ranavira, coordinator of the Data Visualization and Analytics Camp, to present a token of appreciation to Dr. Sandhan Dasanayake as a small gesture of our gratitude. Once again, on behalf of everyone, I would like to convey our heartiest gratitude to Dr. Sandhan for sharing these wonderful things with us. For sure, these will be beneficial for us in our publications. So with that, ladies and gentlemen, we have come to the end of today's proceedings, and it's a kind reminder about the tomorrow